Yeah. Yeah. Good evening, boss. So before I start, can anyone please confirm whether my voice is clear? Right. Fine.
Yes, sir, you are audible.
Fine. Thank you. So in yesterday we had an introductory session in that I was discussing about Apache Spark, why PySpark, need for PySpark, and as compared with other like Python, Scala, Java, and or language. Spark is providing multi-language support as compared with that. Today, Python is the mostly chosen, mostly used for implementing Spark, right? Difference between Python and Scala are the mostly used languages for implementing this. And PySpark features. What are the main features of PySpark and real life usage of PySpark, right? Yes. Yes. Just a second. All right. So I was discussing what is Apache Spark. It is open source distributed cluster computing framework, right? For introduced by Apache Software Foundation. It is an engine. We can say it's a processing engine for big data analysis, processing and computation, right? So say why PySpark is required today. It's a Python API. PySpark is a Python API to use a Spark. It is a so it's mostly used for running distributed SQL, creating a data pipeline, ingesting data into database, running ML algorithms, working with graph algorithms, and working with data streaming. And need for PySpark, Python plus Spark. So yes, need for PySpark means if you see large data is getting generated everywhere. So the data contains of unknown corrections, hidden patterns, market trends, customer preferences, and other useful information, business information, right? We need to extract that valuable information from the raw data. So we require some efficient tools to perform this. We require some efficient tools for performing these operations. So PySpark is such a kind, right? So so I said we need to have some scalable and flexible tools to crack this big data and gain benefit from it. So PySpark is such a kind. So combining Python and Spark is a very efficient for the world of big data. So that's why Apache Spark community came up with a tool called PySpark. It's Python API for Spark. So if you see, mostly like Spark is implemented today by using Python and Scala. Yes, Python is dynamic typed. Python is dynamic typed. This is static type. Means here, no need to define the data types explicitly based upon what value you are assigning. If you're assigning 10 to x, then x is a integer variable created. If you're assigning a float variable, then x is a float variable that is created. Based upon what value, if you're assigning a string value, then a string variable is created. So based upon if you're assigning a list to it, like a list is x is a list object. So if it is a tuple like this, tuple object created. In this way, based upon what value you are assigning to it, based on the value assigned, dynamically it is going to create the variable. That's why we call dynamic typed. So no need to explicitly say int x or float x in this way, right? So dynamically it takes the, and Python has a larger community. Scala has Scala less as compared with Python. So nearly 89,300 inbuilt modules Python is providing for different environments. Python has got powerful libraries, especially for machine learning, graph and streaming and SQL. Libraries are less as compared with Python for Scala. And Python is slower than Scala. The only thing is Scala is faster than Python. Python is slower because interpretation, line by line execution, right? Yeah. PySpark features in-memory computation. In the case of PySpark, loading and processing both happening in the memory level, not a disk level, like memory level storing and memory level processing, right? And massive MPP means massive parallel process. Massive parallel process. Lazy evolution, right? On demand executing the data flow. partitioning, on demand executing the flow, right? It's on demand. It's lazy evolution means whenever required on demand, you will be executing the flow. When the partitioning, Spark data is divided into partitions. The partitions are distributed across multiple systems and processed by multiple systems parallelly. Persistence means reusing already executed transformation. No need to re-execute. In the case of Hadoop, we will be re-executing. We can't reuse, but here in the case of PySpark, we will reuse already executed transformation. Fault tolerant model. Spark has got a powerful fault tolerant model as data is running on multiple systems. Right, it's running parallelly. If any system goes down, then Spark has the capability of regenerating the lost partition, right? That I'll be discussing in the fault tolerant model, how it can regenerate. Immutability. Immutability, right? Yes. Spark data object is immutable, right? So if you see the Spark speed as compared with the other things, right? First you see that speed of that Apache Hadoop, right? So here, previously a test was conducted by Yahoo by taking a table of 100 TB of 1024 columns. Consisting of 1024 columns, task was sorting based on 16 columns. Time taken, right? Yes. Oracle has taken nearly 3.5 days to process this. MySQL has taken around 6 days. Teradata, a specialized database used for data warehouse, it has just taken 4.5 hours. Netija, another data warehouse, is another specialized database used for data warehouse, has just taken 3 hours. But Hadoop has taken just 3.4 minutes. But we talk, okay, Hadoop has taken 3.4 minutes. Spark is 100 times faster than already Hadoop has got a very high speed. But if you see Spark is 100 times faster than Hadoop, just see the speed of Spark. So that's the reason huge data at a quick time, you are going to get the results, right? Through Spark. That's why Spark is mostly preferred today. Very high speed processing technology, which has got massive parallel processing, MPP, and in-memory computation, the main features. Yes. So if we talk about the real life use case, right, it's mostly used in the commercial sector, right? It's mostly used in the commercial sector like banks and financial fields, where Spark is used for retrieving this customer, the social media profile, analyzing and gaining this useful insights, which helps in taking the right decision. And even like credit risk assessments and also in fraud detections, right? And in healthcare, analyzing the patient's records along with the previous medical reports. And entertainment industry, right? It's one of the largest. If you talk about the entertainment, popular OTT platform like Netflix uses Apache Spark for real-time processing for this personalized online movies or web series to its customers, right? Processing around 450 billion events per day, that is streamed over the server side application. Even for trading and e-commerce, right? Like if you see the e-commerce websites like Flipkart, Amazon, they're using Apache Spark for advertising, right? For recommendations, right? Even the other sites are like Alibaba also, they provides offers, enhance customer experience. They are using Apache Spark. Even for tourism industry, comparing like millions of sites, comparing this advice, again providing advice to millions of travelers, comparing hundreds of websites. Okay. One second. If you see some like evolution of Spark, evolution of Spark. Spark was developed by Matisse area, right, in AMP lab. In the year 2009, Spark was developed in the year 2009. Spark was open sourced. It was open sourced in the year 2010. Spark was open sourced in the year 2010. Spark was donated. Apache Software Foundation. Apache Software Foundation, right? Spark was donated to Apache Software Foundation in the year 2013. I say mostly defining Spark. I can define in 4 lines. Spark is a as compared with Hadoop, right? It has got an extra feature. Like here, distributed Spark is a distributed execution framework. It's a distributed execution framework. This feature you can also see in Hadoop and in parallel processor style. In parallel processor style with in-memory computation. This in-memory computation feature you won't see in Hadoop. In-memory computation feature. Used for large-scale data processing. Used for large-scale data processing. Distributed execution framework in a parallel processor style with in-memory computing feature used for large-scale data processing. Okay. What is in-memory computation? In-memory computation. Data gets loaded into RAM. Data gets loaded into RAM and it gets processed. Loaded into RAM and gets processed within the RAM. Here, data divided into partition. Partitions are distributed. Multiple RAMs of multiple slave, multiple slave machines. Right. Divided into partitions. Here, data divided into partitions. And the partitions are distributed across multiple RAMs of multiple slave machines. And are processed parallelly. As I said, Spark can be coded with Spark can be coded with Python, not only Python, other languages like Scala, Java, or language. Yes. Spark. Spark default. Spark by default. Spark default written in Scala language. Scala is the native language of Spark. Spark by default written in Scala. Scala is the native language of Spark. Spark runs on a distributed cluster. Spark can run on Hadoop, AWS. Spark can run on serious Hadoop cluster we say. AWS cluster. Mesos. Yes. If you talk about the execution generations, right? Execution generations. MapReduce. It is one of the excellent parallel execution model which was designed for parallel processing. Hadoop. In to entire Hadoop MapReduce execution is going to happen later, like MapReduce, Sage, Spark. We talk about Sage and Spark. Sage and Spark both follows DAG model. Both follows DAG model. DAG directed acyclic graph. Directed acyclic graph model, right? Both follows a directed acyclic graph model. Sage doesn't follow in-memory computation. Like Spark. Spark has very high speed as compared to Sage. Spark has very high speed as compared to Sage. See, may I ask the other in-memory computing systems. Other in-memory computing systems. HANA. To talk about SAP HANA, right? HANA, if you compare HANA and Spark, commonality between the both follows in-memory computation. Both follows in-memory computation, right? But HANA is not distributed. HANA is not distributed, but Spark is distributed. Spark is a distributed RAM. Spark is a distributed RAM.
But sir, Hadoop and Spark, they do the same thing, right?
Processing node. Spark is also meant for processing. Hadoop performs both storage and processing. Hadoop performs both storage and processing. Hadoop has got a separate file system called Hadoop Distributed File System, HDFS we say. So where huge amount of data, unlimited data storage also can happen, can be stored in Hadoop. And also processing also it can do, right? But as
And
compared,
Spark will use HDFS and it will do the processing.
no. Hadoop will use MapReduce for processing. Spark is a processing engine. And what
Okay.
is that comparison between this just now I showed you right here? If we
Yeah, the 3.4 minutes. Okay.
if Hadoop has taken this, Spark is 100 times faster than that. Already Hadoop has got very less as compared with other things, but Spark is much more faster than that.
Spark also works on HDFS only, right, sir?
Spark can work on that Hadoopian. Here I was saying, right? Spark can run on Hadoopian cluster.
Hadoop, AWS. Okay. Okay.
Hadoopian cluster, AWS, Azure, right? Yes. Spark can run on this Hadoopian cluster. Spark requires a cluster, distributed cluster, right? Yes. So generally, yes. Even you may ask for huge storage, for huge storage, for fast processing. In Hadoop, even there are some components which are mostly used like Apache, Hive, Scoop, these things. So for fast processing, Spark combinedly both can store and process huge data. Unlimited data storage is possible using Hadoop. Unlimited data storage, any number, whatever it is, it can store huge data, unlimited data storage. So if we talk, Spark is mainly designed for it is not for I said it is not for request response architecture. By client server, it won't follow client server. It's mainly for Spark is mainly for batch applications. Batch applications. Batch applications are micro batch applications also, right? Batch applications are see online applications and batch Hadoop Spark is not for online applications. Not for online it is for batch applications. Online applications means user interactive applications. User interacts. Here, user non-interactive applications means millions and trillions of records involved here. But if you talk about online application, even if you have one transaction, for a single transaction, we won't go for Spark. And also mainly Spark is mainly designed for iterative algorithms. Iterative algorithms. What do you mean by the name iterative algorithms? Iterative algorithms, right? Yes. for batch applications, for iterative algorithms. Most of this, if you talk about this ML, machine learning algorithms are iterative in nature. Iterative in nature, right? So just so generally iterative means some, okay. See, for example, there is a tree, there is a fruit. If you want to hit it, first iteration, in the first iteration, you try to hit it, but with a stone, it went like this. It didn't hit. This is the error. Second time, you are going to adjust the coefficients. Second iteration, you are just going to adjust it. When you are trying to hit it, it goes in this way. Now, this is the error has decreased. Third time, again, iteratively, you just tried it. See, this is your error. And in fourth iteration, and the fifth iteration, it is hitting the target. Means you are applying again iteratively until the error becoming zero. Until the error become iterative. See here also, if we talk about the ML algorithms, whenever you are applying it, you will be getting some error until the error becomes zero, until that. So in this way, iterative algorithms, Spark is mainly designed for all iterative kind of algorithms. Okay. And interactive queries, you making the data structured and interacting with that data. Data is in semi-structured, unstructured, if you talk about different file formats. Making it structured and interacting with it. So for interactive queries, right? Even like a SQL kind of querying you can perform. And also for streaming and for graph algorithms. So here we have got components like Spark core programming, Spark SQL, see for interactive this Spark SQL, for this batch application, Spark core, Spark SQL, Spark streaming, Spark GraphX. So many things, right? Yes. Spark supports advanced analytics, right? Spark supports advanced analytics like ML, graph, streaming, interactive queries, right? Yes. And if you talk, I was comparing the technologies, right? Yes. Here comparing Sage and Spark, both are both follows DAG model, but Spark has high speed because Spark is in memory. HANA and Spark, both are in memory, but Spark is a distributed RAM. That's why Spark has got means more storage can be stored. Means distributed RAMs means uh, if you got 10 systems, each system has got, for example, 64 GB. Means totally 640 GB is your RAM storage, distributed storage, right? And if you go with Hadoop MapReduce and Spark. If you go with Hadoop MapReduce and Spark, see, if we talk about this Hadoop MapReduce, means in the Hadoop MapReduce execution happens. We talk about any Hadoop components like Spark, sorry, in Hadoop, any component like Scoop or Hive or Apache Pig or anyway, any components internally MapReduce execution happens. Drawbacks. Here first, MapReduce have these drawbacks, right? Transformations cannot be reused. Here, transformations cannot be reused. Transformations cannot be reused. And also this is bad for iterative algorithms. Bad for iterative algorithms. not a flexible parallel process. Not a flexible parallel process. Here you cannot, in the case of MapReduce Hadoop, right? You cannot control the parallel process. You cannot increase in Spark, you can control the parallel process. You can increase the parallel processing. And as compared to Spark, slow processing. Slow processing, right? Which one? MapReduce. 100 times faster, I said, right? Spark 100 times faster than MapReduce. And if you say Apache pick, yesterday just I was giving discuss Apache pick versus Spark. See here, both are data flow languages. Commonality between these two, both are data flow languages. See, pick Apache pick, right? It's a pig Latin language. It's a simple scripting language with very less coding as compared with other programming languages like Java. I said 100 lines of Java code, you can just write within 7 to 10 lines in Apache Pig. That is what the important feature, and it's very simple scripting language. But here, Pig and Spark both are data flow languages. But in Pig, Pig is one of the component of Hadoop. It was used previously a lot, but now it totally got outdated. The entire data flow. But in Apache Pig, the entire data flow is converted into one MR job and one MapReduce job. It is converted into one MR, means one MapReduce. But as just now we discussed, MapReduce is bad compared with Spark. So if you combine all these advantages, right, Spark advantages are the features from the whatever we have discussed. And if you see, yes, yesterday I was also like Spark and Flink. Spark and Flink. In the initial versions of Spark, yes, Spark was weaker. In terms of analytics. Spark was weaker. In machine learning. But the heart of analytics. ML, machine learning. Before Spark 1.6, before Spark 1.6, Flink dominated. From Spark 1.6, from Spark 1.6. Equal to Flink. From Spark to version. From Spark to version onwards. Now Spark 3.4, that version is running. From Spark 2 version onwards, it totally dominated Flink. Spark introduced powerful libraries. It introduced powerful libraries for ML streaming, graph, etc. Introduced powerful libraries for machine learning, for streaming, and for graphs. So previously it was dominating in the initial versions of Spark. It was weaker in terms of analytics. Right.
Sir, we are going to use Spark 3.4, right, in our sessions?
Yes, yes. Spark. Okay, yes. Now, powerful libraries for ML, streaming, graph, etc. Right? Yes. Now, if we talk about Spark data objects, Spark data objects. RDD. What is RDD? Spark data objects we call it as RDD. Resilient, resilient, resilient distributed data sets. What is that? Resilient distributed data sets. Hadoop data objects. Files. Spark data objects. RDD data frame, DS train. Okay. We talk about RTD, resilient distributed, and RTD is again subdivided into partitions. RTD is again subdivided into partitions. These partitions are distributed. These partitions multiple RAMs, multiple slaves. These partitions are distributed across multiple RAMs of multiple slaves and are processed parallelly. RTD programming style. Data flow. What is data flow? Data flow is a sequence collection of pipes. This is a sequence collection of pipes. RTD is a sequence collection of pipes. Types of RTD. A pipe. Any data operation. loading the data. It can be any data operation such as loading the data, transforming the data, filtering the data, merging the data, loading data, transforming the data, filtering the data, merging the data. Yeah, for example, here some. So loading data, transforming data, filtering the data, merging the data, grouping data, it can be any of this. In Spark, data flow is executed. Data flow is executed sequentially. In Spark, data flow is executed sequentially. That is RTD by RTD. That is RTD by RTD. One after the another. In Spark, data flow is executed sequentially. That is RTD by RTD. One after the another. In DAG style. In DAG style. With in-memory computing. With in-memory computing. And a persistence feature. RTD by RTD, one after the another in DAG style with in-memory computing and persistence feature. Two RTDs cannot execute in parallel. Two RTDs cannot execute in parallel. Two RTDs cannot execute in parallel because RTD1 RTD2 RTD1 output is input to this. RTD1 output is the input to this RTD2. Until RTD1 execution completed, its output should be given as input to RTD. Until then, RTD2 cannot execute. Two RTDs cannot execute in parallel. RTD1 output as the input to RTD2. Similarly, RTD2 output input to the RTD3. Into RTD3. RTD1 output is the input to RTD2. RTD2 output is the input to RTD3. Until RTD1 partitions Until RTD partition ones are computed, RTD1 partition until RTD1 partitions executions are completed. RTD2 cannot execute. The output of one is input to the next. Three RTDs, RTD1, RTD2, RTD3 cannot execute in parallel. RTD, why by RTD? Yes. Data flow is executed sequentially RTD by RTD, one after the another in DAG style within memory computing, right? All the three RTDs. But if a RTD has 20 partitions, if a RTD has 20 partitions, load across 20 slaves. But if a RTD has 20 partitions, these can execute parallelly. These 20 partitions can execute parallelly. As these are stored. And are executed parallelly and provides the output.
So
If
how
you
can we
are
decide for this much of data how many partitions we have?
See, whenever you are loading the file in Spark, I said in Spark we can control the partitions. This parallel processing. Whenever we are loading the data file, right? There we can give the number of partitions, how many.
Yeah, that we can give. So let's say, for example, we are having 2 GB of data we are loading. So on that time, how can we decide? So these many partitions we need to
Depending upon your cluster capacity, right? Or what is that number of slaves, you can provide it. If you have got 20 systems, 20 they will be distributed across 20 systems. If you have got depending upon your cluster capacity, you can give that partition size.
Okay.
Sir,
So it's main.
if I have 20 clusters, will it be replicated in all 20 or it is based upon whatever is our
Why 20 cluster, right? 20 systems you say.
20 systems?
Okay. 20 systems, right? It means your data is going to be divided into 20 partitions. 20 partitions distributed across 20 systems and are executed parallelly. That too within the RAM level they will be stored. Right? And are executed parallelly. So depending on how much you will decide means you already come to know about your cluster capacity, right? How many nodes systems you have got. 40 node cluster or 60 node cluster or what, depending upon that, you can increase. Right?
Are we going to do some kind of practical session, sir? Like
Yes, totally. I said right. Just for yesterday, I was saying for 3-4 days, first 3-4 sessions only, you will see you will be discussing about this Spark data objects and the Spark architecture, right? But later on, everything will be practicals. There won't be any theory at all.
Sure.
So everything I'll be discussing, I'll be showing you, right? RTD dot get num partitions.
Hello,
So
sir.
this is the command to get the number of partitions, right? If any particular RTD dot get num partitions, it is going to returns the number of partitions. Returns the number of partitions present within a RTD. Within a
Hello, sir. I am audible?
yes. Now, yeah, some query was asked.
Yes.
Yes. Go
So
ahead.
in our scenario, likewise, RDD1 output is going to the RDD2 output, and RDD2 output is going to the RDD3. Okay. So in my scenario, if I need RDD1 output to the RDD3,
Hmm.
and the whole data of RDD1 got erased due to some reason. So can we
RTD1.
retrieve the RDD1 data get erased due
Okay.
to some
That's
reason,
yes.
and I need the output
Hmm.
and the actual raw data of that RDD1 to the RDD3.
Okay.
So it
Yes,
will,
yes.
we
Yeah.
can retrieve it, or we will lose the data.
Okay. 1 second. So check with this, right? So generally, only you see, okay, RTD1, RDD2, RDD3, RDD4, RDD5. In this way, many RTDs are there. All these RTDs, where they are getting stored, first, okay, I'll come back to your query within this example. So here, where all these RTDs are stored within the RAM level, memory level. Okay. Do you think the RAM can it accommodate all these things? This each RTD is a bigger, huge data. Each RTD is a bigger data value. Do you think all the RTDs can be accommodated by this within this RAM?
No, sir.
No,
All the
no,
RTDs. Think that if you think
No.
that 20 RTDs are there, 20 RTDs cannot be loaded into the and cannot be accommodated by the RAM. If you think one RTD size is, for example, 1 TB, you think, or like 50 GB, you think, or 1 GB, what is 50 GB or 1 TB, whatever it is. 20 RTDs, this much, this many RTDs can't be accommodated by the RAMs. They cannot. And one more thing, do you think all the RTDs will be loaded into RAM at a time? Do you think all
no,
the RTDs will be loaded into RAM at a time into that RAM? No, right? So here,
no,
first, how this RTD1 is created? RTD1 is created means you have got a file, you have got a file, a text, a CSV file, or a text file, or a Parquet file, whatever the file format it is, you got a file. For example, I have got some employees.csv file. The file path where it is present, everything, the path using a Spark context dot some text file, or you got this. Whenever you provide the Spark context, whenever you are loading a file, whenever, see, there are three ways to create an RTD. This is one way of creating an RTD. If you load a file using a Spark context, then a RTD gets created. And here RTD1 created, RTD1 is divided into, think that RTD1 divided into 10 partitions, P1, P2 up to P10, right? This 10 partitions stored across 10 systems, S1, S2 up to S10. They're executed parallelly. Here parallel processing you are going to see. Once this execution completed, RTD1 output is taken by RTD2. This output is taken as the input by RTD2. Means how this RTD2 is generated. Initially, there is no RTD. First, from the file, RTD1 got generated. From RTD1, RTD2 got generated. Whenever, if you perform any transformation on an RTD, the result is also an RTD. If you perform any kind of transformations, filterings, right, on RTD1, I am performing some filter operation based on some city equal to Hyderabad, or from department number equal to so and so, or product equal to so and so. Now RTD2 got created. From RTD1, RTD2 got created, the result of RTD. But RTD1 is not disturbed. Don't think RTD1, Spark data objects are immutable. It's not modified. The original RTD. From that RTD1, RTD2 got generated. Again from RTD2, RTD2 dot perform any transformation like a grouping or anything, right? Yes. RTD3 got group by key we say, right? Again from RTD3, RTD4, from RTD4, it doesn't mean that from RTD3 it has just now someone asked, right? From RTD2 only it got generated. From RTD2, RTD4 got generated, or RTD3 from RTD3, anything it is. from RTD4, RTD5 got sent. Means first thing from a file, RTD1 is created. I'm saying just R1 here. R2 created. Next R3 created. R4 created. R5 created. From a file. So this entire data flow. This is your data flow. This is your entire data flow. This entire data flow is lazy evolution, right? Lazy evolution. Until you perform some kind of action, this entire data flow won't execute. Okay, you perform some action. This entire data flow executes. First, from the file, this RTD1 gets created. These partitions will be loaded. These partitions will be loaded and executed parallelly. This output as taken as input by this. Now RTD2 is loaded. Now RTD2 got computed. Observe carefully here. Even you need to, all the RTDs never gets loaded into the RAM at a time, because until RTD1 execution is completed, RTD2 can't be loaded or can't be executed. So once RTD1 loaded, execution finished, its output collected by RTD2, RTD2 also loaded, computed, means after some series of RTDs, 20 RTDs, right? How many RTDs you will see in the RAM? Whenever RTD20 is getting executed, how many RTDs you will see in the RAM?
Only R20, sir.
Only R20.
The last RTD.
So here when R2 is loaded and computed, R1 gets removed from the RAM. When R2 is loaded, computed, all its partitions executed, and its output is taken by R3, and when R3 loaded, executed, R2 will be removed from it. When R4 is ready, loaded, computed, this gets removed. When R5 is loaded, computed, this gets removed from the RAM. Parts. Because if you keep on loading RTDs, at a point of time, there won't be any space for the incoming RTDs. That's the reason it is going to clear the previous things. When the new one is getting loaded, the previous one it gets removed. Now that out, I want R5 output. This is my final output. There's a series of RTDs in a data flow. Finally, you want the output of this. Once this output is collected, once this output is collected, once the total execution is completed, once the total data flow execution is completed, right? This last one also gets removed from the RAM. The
But
last
sir,
one also.
we have mentioned that in a definition, the RDD is a persistence. So it may be cached in a memory or it will be erased the previous RDDs.
See, RTD is a bigger data object. RTD is a bigger data object. It's not like a small thing, right? Already you are storing in the memory level, not in the disk level storage. It will be totally be cleared. Until then, the next upcoming RTDs cannot be loaded, right? Totally, it will be clear. RTD is immutable only. Immutable means what? Mutability and immutability means what? Yeah. Observe here.
Immutable cannot change.
Immutable means you cannot change or modify it.
Yes.
But what is, okay, immutable, we are not changing or modifying it. R1 will be there, R2 from R1, R2, R3. So first, this R1, R2, R3, initially they are declared. Once you trigger the, once you trigger them, one by one gets loaded and computed. And at the same time, whenever the next one is ready, the previous one gets removed from the RAM. Right? So what happens if you keep on loading the RTDs without deleting, right? Once if 20 RTDs, when the 21st RTD, there won't be any space in the RAM available, right? So it has to clear that previous thing. So at a time, it will clear and loads, clear and loads, clear and loads. Once the total data flow is executed, the final RTD also removed from the RAM. Now no RTD in the RAM. It's totally cleared. We can trigger the next data flow.
So the by default replication factor rule also is not applicable for these partitions.
Replication, you can see in Hadoop, but in Spark you won't see that replication.
Okay, so thank you.
Okay. Mm, just a second. Okay, understood, right? This and how this RTD's computation, the persistence, fault tolerance means if you may get multiple queries here. You might be getting multiple queries. You are saying that R1 is an RTD. It is divided into multiple partitions, 20 partitions, 20 partitions stored across 20 systems. As they are systems, they are machines. Suddenly, if any system goes down, there is a chance of means a particular P2 partition is lost. P2 partition means data is lost. Means Spark has got the, just now someone asked, right? Can we, if this R1 is lost or if it is can we regain? Yes, Spark has got the capability of regaining the lost partitions, right, of an outage. So again, from the file, it is going to, if R1, it will take the data from that, and again R1 will be generated. Again, this flow gets executed. And there is a concept called persistence, right? If there are 100 RTDs are there, if 97th RTD is the machine is done, again you need to execute. See, this somewhere the flow need to be start from the starting. In such case, persistence is there. Persistence is just like a kind of commit, you can say. Persistence is a kind of like a commit operation, you can say, right? So if you are committing, for example, R1 to R100, R50, if it is persisted, if tomorrow, like if anything, no need to re-execute from R1, you can execute from R50 onwards. So that about this persistence, fault tolerance, computation of RTDs over the cluster side, right? I'll be discussing it. So just introduction to Spark. So I was saying like Spark has got very high speed as compared with this other technologies. So all these notes I'll be forwarding to you, right? These things, whatever we have discussed, right, today and yesterday. So you'll be getting the clear notes. You will be getting the videos on daily basis, even if you miss any session, right? So it's a weekend batch. You might be having, okay, if you miss any session, you'll be getting the video of it. So you can go to the video and attend the next session for the better understanding. Clear notes, videos, assignments and tasks will be provided. And a WhatsApp group will be created to have direct discussion with me, right? Direct interaction. If you got any error, you can take the snap of it and you can keep in that. And okay. So yes, next week, next Saturday, we'll be starting with the actual things, right? So just I was explained today, I was just briefing you about introduction to Spark, the features of Spark as compared with other technologies, right? So next Saturday onwards, we'll be starting with the actual thing. So this computation of this RTDs, fault tolerance model, different persistence options, what is persistence and what are the rules to be followed in the persistence, right? So before we go with the practical, but once the practicals are started, there won't be any theoretical, right? So first 2-3 days, 2-3 sessions, you'll be seeing some kind of these things. Fine. So in the just people who have enrolled for both big data and Spark, okay, that's fine. But people who are getting enrolled for only PySpark, right? So just get enrolled for getting the videos. So by tomorrow, yes, sir. By tomorrow afternoon, tomorrow by 11 o'clock, you'll be getting the videos. You'll be getting the notes of this. Okay, and notes I can forward now itself. These things, right? This entire notes I can keep in the chart now itself. But generally, you'll be getting to the mail or in the WhatsApp, you'll be getting this. So for getting these notes, for getting the videos, for getting added to the WhatsApp group, right? Just to get enrolled for this PySpark. So one thing, once again, I say for the sessions need to be interactive sessions. I want you people to respond whether your answers are correct or wrong. Attending the sessions regularly for the better understandings and also doing the practicals for the better understanding for the basics if you are doing. Okay, so just this Python syntax is just like I'll take it's not complex syntaxes, right? Just I'll brief you with some. I'll take a session or two on this Python syntaxes before I go with the actual execution, right? Yes. And about the software also, I'll be demonstrating it. Yes. Okay.
Sir, can I get Your email address, sir. I want to talk to you.
Okay, can you see in the, okay,
Can you please message, sir, or the group?
one second, one second. Yes, Chandrasekhar Jairam, right? It's an ongoing batch, right? It's confirmed, right? And
Yes,
you
sir.
can see, if anyone, if you have missed that yesterday's session, right, you can see the video link is given in the chart, the Zoom chart, the DurgaSoft online team, they have forwarded a message. You can go to that message, right? And if you see, one second, the course content, yesterday's video link is given, the payment details, and if anyone who not enrolled, right? And also the contact details, you can see the contact details there, right? And the payment details, everything is kept there. And for any queries, they provided 4 contact details, the payment details, the course content details, right? Once again, you can have a look on this course content in brief, in depth. The entire PySpark is discussed here. It's an exclusive course on this PySpark. Total PySpark, all these functionalities will be discussed, right? PySpark sessions, PySpark context RTDs, PySpark RTDs computation, RTD persistence options, PySpark core computing, right? Different ways of creating RTDs, increasing the number of partitions, aggregations over structured data, groupings and aggregations, right? Various groupings and aggregations, reduce by key, group by key, various built-in transformations. In Spark, you have got many built-in actions and built-in transformations available. All these things, right, we'll be discussing one by one, right, with the working examples. Spark data frames, right, making the data structure and creating like a tabular kind of structure. How we are going to perform with different functionalities, select, collect with column, where, filter, order by, group by, join. So if you talk about in other ETL tools, you'll be getting, but here we have got functions for all that inbuilt functions are there. We can perform by using this, right? And also PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, built-in functions, when expr lit can get to see all these other built-in functions, and external sources, Spark and Hive integration, Spark and database integration, working with the different file formats, transforming narrow and wide transformations, adding columns, dropping columns, renaming columns, handling nulls, and writing back to the external sources, right? Writing at the data frame to the different other file formats, deployment mode, local mode, cluster mode, PySpark application stages and task, driver and executor, building Spark applications, deploying Spark applications to cluster, performance tuning, PySpark streaming concepts, integration with Kafka, and PySpark machine learning library. So I'm just going to show you this execution on different environments, right? So within this, I'm going to provide image, VMware image, in that you can, or in the Windows, you can execute, in Jupyter Notebook, you can execute, in Databricks Notebook, you can execute this Spark code. All this I'll be showing you, right, and different environments how to execute. Yes. Yeah. Okay, fine. Any other queries from your side, anyone? All the sessions will be interactive. You will be kept in unmuted status. At any point during the sessions, you can unmute and you can ask the queries, or you can type the queries in the chat. Right. Clear notes, the videos, as I said, you'll be getting it. And also even during the practice, if you get, means, yes, it's a weekend batch. Whenever you are practicing, if you get any error, no need to wait until the next week. In the WhatsApp group, you can just take the snap of it, the error, and you can post, and I'll be communicating there, right? Okay, fine. Any other queries? Yes. So next Saturday, yes, at same time at 6:30, but the link will be changed. So get enrolled for getting the link to your mails. People who have already got enrolled, right? If you have taken that package of Hadoop and Spark, okay, you'll be getting the link directly, or you'll be kept. The people who wants enrolling for PySpark, right? Check with the things, right? Thank you all for your time. Thank you. Meet you on next Saturday. Right.
Thank you, sir.
Thank you, sir. Thank you.
Mhm.